This problem is about the Newton's empirical law of cooling. So it says that when a cake is removed from an oven, its temperature is measured at 150 degrees centigrade. 3 minutes later, its temperature is 90 degrees centigrade. How long will it take for the cake to cool off to a room temperature of 20 degrees centigrade? So first of all, let me tell you what the Newton's law, empirical law of cooling is. It says that the change in temperature so the change in temperature dt over dt with time, with capital T is the time, is proportional to the the temperature minus the ambient temperature Tm. Okay, so it may be, if we are talking about the cooling, so that means this temperature T is higher than this ambient temperature. So we may call it as a room temperature as well. So this proportionality constant can be converted into a equality, but by multiplying with the constant. So this equation then can be, this is a differential equations which is separable. So dt over T minus Tm. So here we are assuming that this ambient temperature is a constant. It will be K times dt. So taking the integration of both sides, so it will be T minus Tm will be equal to Kt plus C, or T minus T will be equal to, if we simplify, T will be equal to Tm plus C times exponent of Kt. So this will be the equation. So if we apply this equation so for this given problem, so it says that here we will see that at time t, okay, that means at initially the temperature will be T. Okay, initially the temperature will be T. So that means T as a function of 0. Okay, the temperature will be T. So we can say that T is equal to no, in this given problem, what is T? So T is equal to 150 degrees centigrade. Okay. So initially the temperature will be 150 degrees centigrade. 150. So the value of T will be 150 is equal to T. Ambient temperature is 20 degrees centigrade. Okay, so we will take it as 20 degrees centigrade. 20 degrees centigrade plus C, and C we need to find, and we also don't know about K, but anyway, K into 0. So it will be, then this term will be 1. C e power 0 is 1, so therefore C will be equal to 150 minus 20, that will be 130. Okay, so this will be the value of C. Later, now we can also find apply the second condition. It says 3 minutes later its temperature is 90 degrees centigrade. So T at 3 minutes is equal to 90. So now we can apply this, like input these values. So 90, T is equal to 90. Tm, we already found that it is 130. And sorry, Tm is not 130, it is C which is 130. So Tm is 20 and C is 130, then e power k into 3. Okay, so from here we can determine the value of k. So the k value of k will be, then we need to simplify it. 90 minus 20 is 70. So e power 3k is equal to 90 minus 20 is 70 divided by 130, or that means it is 7 by 13. So 3k is equal to, will be equal to log 7 by 13. Okay, and then from here we can find that k is equal to 1/3 of, k is equal to 1 by 3 log 7 by 13. So this is the value of k. So now it is asked that how long will it take for the cake to cool off to a room temperature of 20 degrees centigrade. So we need to find the time t for, we need to find time t for the temperature to become equal to 20 degrees centigrade. However, this is practically not possible to determine because of the equation. Okay, this, for example, now we are going to find t is equal to 20, and now Tm is also 20, and then plus C, which is 130, and then e power 1 log 7 by 13 power 1 by 3. Okay, I can take this 1 by 3 into inside. So, but here if you see that if it is 20 minus 20, so then e power this will become equal to 0. So we will not get any solution of t over here because t will be very long, infinity. So for all practical reasons we will say that maybe instead of room temperature to become 20 degrees centigrade, it maybe it's very near to 20, such as say I can take a value of, say, value of t, say maybe about 20.1 degrees centigrade. Okay, so how long will it take for the 20 point, or for all practical reasons maybe 21 degrees centigrade. Okay, I can take it as 21 degrees centigrade. Okay, so 21. So if I input 21 over here, then we will have some reasonable answer. Okay, so if I solve from here, then it will be, so as I will see, e power log of 7 by 13 power 1 by 3 k. Okay, this will be equal to 21 minus 20 is 1 over 130. And now we can, I can solve it like take the exponentiation for both sides. So it will be log of 7 by 13 power 1 by 3 times 3 will be equal to log of 1 by 30, 130. So by using your calculators we can find the value of t from here. So t here will be about 23.5, 23.6 minute, 23.6 minute. So after that the drop in temperature will be very small. Okay, so at 23.6 minutes the temperature will reach 21 degrees centigrade, but from 21 to 20 degrees centigrade it will take very long time. Okay, because here the difference is very small between T and Tm. When the difference is very small, so that means the rate of temperature change will be also very small. So for 20 degrees centigrade it will take an infinite amount of time. So if we plot the graph between the time and the temperature, and if this is 20 degrees centigrade, so this is the 20 degree, and then it will be like this. Okay, so we can give an arbitrary answer that at 23.46 or 23.6 minutes it will be almost 21 degrees centigrade, and from there on I think it will take very long time to reach at 20 degrees centigrade, but or rather it will take an infinite amount of time to reach it. It's because of the type of equation we have used, which is an exponential equation, so that's why it will take quite a long time.